right, good morning, ladies and gentlemen. Hope you guys are doing well. This is another video going through physical science. I'm Mr. Kenton, so thank you guys for joining me this morning. And today we're going to be starting a new unit. We're going to be looking at and building on our understanding of chemistry by looking at the periodic table. Okay, so follow along with me. Make sure that as you're watching through these videos, you're taking notes. And feel free to pause them, the videos at any time, go back, rewatch them, make sure that you're catching everything. So we're going to look at the periodic table, which we started introducing ourselves really in the last unit, right? And so before we dive into the information, what's new, what we're going to be looking at, I want us to take a look at what our objectives and the state standards. So in North Carolina, these are the things that I'm hoping that we're going to be able to do by the end of this particular unit. And so if you look at the first thing there, I want you guys to be able to classify an element as a metal, non-metal, or metalloid based on its location on the periodic table. Essentially what I want you guys to be able to do is if I give you an element, you should be able to tell me, is it a metal, is it a non-metal, or is it a metalloid, right? Next, you need to be able to construct dot diagrams, which is a shorthand notation for Bohr models that uses the element symbol and dots to represent the electrons in the outermost energy level. All right, and so the really cool thing about that is it's going to build on your understanding that you developed in the previous unit. Okay, and lastly, I want you guys to be able to infer or determine the number of valence electrons an element has, its oxidation number, and the reactivity of the element based simply on its location on the periodic table. And that sounds like a lot of information that you get just by looking at where an element is on the periodic table. But as we move forward, you're going to see that that's going to actually be pretty doable. So let's jump in with kind of an introduction to the periodic table to kind of start us off with. So I want us to first take a look back because within chemistry and what we're looking at, almost always the thing that we learned about previously is going to have an impact on what it is that we're doing currently. And so I want you to remember that in the last unit, we spent a good deal of time talking about atoms, ions, and isotopes, right? And we talked about how we could determine the number of protons, neutrons, and electrons for a particular atom. And in order for us to do that, we had to look at the periodic table to do so. Now, again, we saw that that was some of the useful information that we could find, like those numbers of protons, neutrons, and electrons. But now what we're going to be doing is we're going to build on that understanding, and we're going to be moving to looking at the arrangement of the periodic table. Why are the elements placed where they are on the periodic table? Did someone just kind of determine, hey, this is how we're going to arrange it? Or is there a meaning or a pattern or something that's going to give us some insight as to why the elements are where they are on the periodic table? And hopefully we're going to answer those questions. So let's jump in to looking at the periodic table. Now, obviously for us as scientists and as chemists and for you guys, the periodic table is just an extremely useful tool for chemists, right? You think about for people who play sports, like a baseball player, their baseball bat and their glove are an essential tool to help them be successful. A basketball player, their shoes are an extremely vital aspect. For a tennis player, the racket that they're using, it's an extension of them being able to complete a task. And so for us as chemists, the periodic table is that extension for us. It is something that is invaluable, and it provides us with a lot of information that we go back to, right? Because on the periodic table, we can find the following information. We can find the elements, right? We can determine what type of element it is, whether it's a metal, a non-metal, or a metalloid, just by looking at the periodic table. We can determine the number of valence electrons that an element has just by simply looking at the periodic table. We can also look at, based on its location, the number of energy levels that that particular atom has, again, just by simply looking at the periodic table. Obviously, we can find element symbols, we can find average atomic masses, and so we can find all of this different information just by looking at the table and understanding what it's trying to communicate to us. And interestingly enough, when you think about that the term, like, why is it called the periodic table? Really, the word periodic here is not just talking about something that's sporadic or occurs every now and then. When chemists came up with the idea of the periodic table, they were thinking of periodic in the context of meaning repeated in a pattern. And so as we begin to look at the periodic table, there should be some patterns that we're going to begin to notice that we should be able to unpack and be able to use to help us better understand what's on the periodic table, right? So as we're going forward, I want you to think about what repeated patterns is the periodic table showing us with respect to the elements that are found on it. Now, last thing that I want us to look at for our intro here is just looking at a brief history of the periodic table, okay? Because like many things in science, the periodic table has changed and adjusted over time. And we first want to go to looking at Dmitri Mendeleev. Now, that might be a name that you're familiar with, but he is the first person that was credited with organizing the elements into what we would call a periodic table. Okay, obviously his periodic table looked very different than what we have today, but he's the first person who gets credit for putting something like this together. Okay, and when you look at his original periodic table, one of the things that you notice is that he arranged the elements in columns, right? So think about a column, that's something that's moving up and down. He arranged the elements in columns based on similar physical and chemical properties of those particular elements, right? And so remember, if you're not familiar, remember, go back and look at physical and chemical properties. That was our first chemistry unit. Now, his overall scheme in organizing his elements was based on average atomic mass. So if you think back to our work in the previous unit, that was that decimal number that was found in the element symbol. And so his arrangement was, let me place the elements on the periodic table based on an increasing average atomic mass. Now, Dmitri Mendeleev's periodic table is not what matches up with the current periodic table. So Mendeleev got the ball rolling for this particular idea, and it wasn't until Henry Moseley, a British scientist in the 1900s, came along that we really start to see the periodic table take shape and kind of hang on to a specific pattern that we see today. Now, so again, Henry Moseley, he was a British scientist, and he's the one who we give the most credit to for the current arrangement of the periodic table, right? And so, again, what Moseley did, just like Mendeleev, he arranged elements and organized them on the periodic table based on those similar physical and chemical properties. That didn't change, but instead of looking at the average atomic mass for an element and using that as kind of the arrangement order, he looked at the atomic number. He used Z, which is that number of protons, to help arrange the elements on the periodic table. And if you look at the periodic table today, as you read it from going left to right, it's going to go based on increasing atomic number. So starting with hydrogen, number 1, and then you start reading across, it goes 1, 2, 3, 4, 5, 6, 7, so on and so forth. And so Mendeleev and Mosely both provided just a tremendous amount of information and a lot of groundwork for our current understanding and current structure of the periodic table. Okay, so that's going to cover our intro. I want you to just take a look at this, make sure that you're taking notes on this, and I want you to think about how might the information that we're looking at now be useful to us moving in the future. Thank you guys for joining me, and I look forward to seeing you guys again soon.